Good evening. Today we are going to see this third video that is related with your term work examination. So already we are with this. Second, we have seen different cross sections we have seen. That is rolled section we have, after rolled section, we have built up section, and we have only cables we are going to consider in tension member other than your compression member. Then we have seen different buckling class. We have A, B, C, D depending upon your dimensions, that is B upon H value, TF value. And then we have seen that effective length and four conditions mainly we have seen. One end fixed, other end free we have. Then second we have that is both end fixed. Then we have both end hinged, and then we have one end fixed, other end hinged. So likewise we are with this. Now we will go for third sheet, and in third sheet we can have, this is plan front and side elevation of slab base. So here we have slab base, then here we have gusseted base, then this effective area of base plate. So actually we need not require to go for this. We do not have this actually in syllabus. And then last we have that is list and batten columns. So we have these four parts of sheet number 3. So now we will go directly to the sheet number 3 after your effective length. So now we have this elevation. So you can see this here. We have this. We have base plate. That is slab base, or we can say base plate. So we have this angle section. This is ISHB column. Whatever may be 300, 400. So this is column section. And load we are going to transport by bearing only. So this angle cleat, this is only to connect these two. This we are not going to design. Now in oral they may say you draw slab base, plan front elevation and side elevation. So we should be in position to draw this. Generally we are going to plot this. If we will go to below, then you can see we have, this will be, this is your base plate, this is your concrete portion actually. So this is base plate, then this is cleat angle, you can see this. So we have this line of cleat angle, this will be second leg of the cleat angle. Then this is I section. So we have this as I section. And in the same way we have on this side. So that you have to keep in mind where we have to plot. Otherwise you will plot front elevation. Suppose you have plotted this front elevation, and then somewhere you are going to plot this. So that is not matching your lines. So you should be very careful. Here you have I section, you have to plot in the same fashion, cleat angle and all these things. Now if you will go for side elevation, then you are going to get these. So now this is IHHB 300. This is web portion. You can see this is web. And then we have, this is flange. So we are going to get flange on this side. And then from this, you are going to get these two dotted line. So you should understand when we are going to get dotted line, when we are going to get full line. You should be in position to understand this. So you can see this. So this is my thickness of web. So this is TW. And this is thickness of flange. That you should be in position to show it. Now you can see this angle. So this line again should be matching. So we have, this will be your cleat angle. So you can see this. So this is thickness of cleat angle. You have to see this. Whatever diagrams you have plotted. So you can check it once in oral. He may see your sheet and ask question on this. And if these are not matching, then he may have questions on it. So you have to keep in mind, you can see this. So these, we are going to provide these 2 bolts we have over here for clit angle, and then we have these 2 bolts. Now these bolts are not with your beam, so these are not shown over here. So these slab base, and you know we are going to use formula of TW that is given in IS code. Now I already mentioned you have to go to YouTube channel, you have to see playlist, and in playlist you have oral questions. Now you should be very careful with these oral questions, and then you have playlist for DSS, that is for your theory, and you have DSS, that is for your term work also. So if possible, go through all these, see videos related with your term work. There all things are explained, and this theory also you can have videos you can see whichever you are not in position to answer it. Then we have plan front elevation gusseted place. Actually, these we are going to apply for low loads. That is slab base. So we have actually bases. We have first 2 types. One axially loaded, and the second we have that is eccentrically loaded. Then in axially loaded, we are going to be with 2, that is slab base, and second we have gusseted base. And here actually we have this slab or gusseted base, but we are going to divide it into 3 parts. Already we have seen. We have first that value, that is E less than or equal to B by 6. So whole portion is in compression between B by 6 to B by 3. So we have this will be second portion, and third portion that is greater than B by 3. So likewise, actually you just go properly to this eccentrically loaded. We have already videos on this, and go through this. You may have question because you have eccentrically loaded. If you will go eccentrically loaded video that already uploaded on this, so this value just see in this video. So now we have second, that is gusseted base. Now in gusseted base, you have to keep in mind we have this as ISHB column section. Then we have, so these lines, this is these 2 lines I can mention. So from both sides, this is your thickness of flange. And then these next 2, I will say this is gusset plate. Now generally this is of 16 millimeter. No, sorry, this is only plate. So ISHB with plates. And then this actually we have gusset plate. This is 16 millimeter generally, 16, 20 likewise. This is gusset angle. This angle is generally taken as 115, 150, 15. So these generally are not designed, these are generally assumed values. And then you have this as gusset plate. Gusset plate. Now you can see this, a plan of this. You can see we have this will be column, and this column beam and plate. So beam with plate, this is column section. So this plate I will mention, that is thickness, this one. So this is full, we have throughout the length of the column. Gusset plate we have around 1 meter likewise. Now you can see this gusset plate we have again throughout this base plate. Whatever size of base plate, that will be width of base plate. This plate we do not have likewise. This is beyond your column, that is 50 or 100 as per your requirement of the compressive force. So now you can see this. So we have these two. One we have gusset plate. Second we have angle. So this is gusset plate. Thickness of gusset plate. This is thickness of gusset angle. Then we have this as width of gusset angle. So you can see this. These lines are matching. So that is most important. When you have asked to draw this, some oral examiner may ask you draw this plan elevation and side elevation. You should be in position to draw this. So now you can have this gusset plate angle, and then we have this beam plate likewise. So you can see this. So we have these two lines. Now you are going to see this. This is our thickness of web. Now here you can see, you cannot see these beam. So whatever dark line, these dark line are of this plate. So this plate you are going to see in full. So if you will see from this, you are going to see this outer plate, not inner column flange. And therefore, whatever these two dotted line, this dotted line and this dotted line, these are for beam. So this is your width of flange for beam. And then we have this as thickness of plate attached. And then we have remaining, that is design of bolts and all this. So I will not go in that design, that you have to go through these videos. Then actually this was figure 9 we have taken because that is given in IS at figure 9, but we do not have question on this. You can mention that is in your oral also. This part not taught us by our staff members, and this is not in our syllabus also. Then we have next part, that is figure 10. Now you go to this, because in oral examination he may ask you write down design step for list column, write down design step for battened column. So you should be in position to write design step. I already mentioned over there. So you have to go. We have videos, that is revision lectures we have for INSEM also. And in INSEM, we have this laced column and batten column. He may give you some load that is 1200 kilonewton and just find the cross section. In that case, you should be in position. Or he may ask you what are different criteria for laced column and what are different criteria for batten column. So we have video that is of batten also, and video that is of laced column also. So go through it, and then you can have this for your oral beneficial. So now, and that single list, then we have double list. So these columns we have shown over here, and you should be in position to show this. So this will be your single lacing, this will be your double lacing, that is already given in IS code. It should be mirror image. So you can see this, that is lacing on face A, and if you will take it on backside, then we have these are exactly matching. So we have mirror image of this. Same way we have here. Then you should know all the criteria, what will be width, what will be thickness for batten column, single, for double, for your single lacing, double lacing batten, that you should know. So through go and see the design of steps of this, then design of this, what are the criteria for design of batten column in detail. I will not go for this, but you should be in position to know all the steps, to know all the clauses which are related with your laced and batten column. So now we will stop here only. So this is related with your sheet number 3. So in next video, we will see sheet number 4. So thank you.